Okay, so the next concept we're going to talk about is an indefinite integral or just an integral here. Is just this just says that we're going to take the antiderivative of this function, right? F of x is what's called an integrand. The integrand is whatever's inside the integral. Oops. All right, so for example, the integral of x squared, if I take the antiderivative of x squared, it would be x cubed over 3 plus a c. So this is just a different notation of what we were doing. All right, so well, this spacing is really bad. All right, I'll fix this later, but this should be on next page. All right, so let's look at this first example here. Let me just add a new page. Search. All right, so I'm going to copy these three questions here. Integral of 2 root x. All right. All right, so we're taking the integral of 2 root x plus 7 root x. Let's go ahead and all right. Okay, so essentially what we're doing is we're taking the antiderivative of these two pieces. So what I'm going to do, right, notice the way I wrote that is you start with an x and you curl the tail back here. So this is 2x to the 1/2 power, and then 7x to the negative 1/2 power. Right, so I'm just changing it to a power. So I can use the power over here. Okay. When you take the antiderivative, this goes away, this goes away. An antiderivative of this using the power rule, you add 1. So 1/2 plus 1 would be 3/2 divided by 3/2. And then negative 1/2 plus 1 is a positive 1/2. And then don't forget that you get a plus c. If there's no simplification needed, you can leave it like this. Otherwise, you can change flip, right? 2x to the 3/2 times 2/3. That's a 4/3 x to the 3/2. This is 7x to the 1/2 times a 2. That's a 14x to the 1/2 power. Don't forget the plus c. All right, so there's my answer here. Let's look at the next example. Right, this is similar to a question we've seen already. Right, so x is the same thing as x to the first power. Root x is x to the 1/2 power. And if you just kind of write the coefficient off to the side, so you don't have to worry about it, I can write it as x to the negative 1/3. All right, and before I start doing the integration, I can combine these two things. When you multiply the same base, you're going to add the exponents. So that's a 3/2 there. 1 plus 1/2. All right. So we're just doing a rewrite, and then we're going to use the power rule. Right, this is integration power rule. All right, so the antiderivative of x to the 3 halves is x to the 5 halves. Right, add 1 to the exponent. All right, negative 1/3 plus 1 is a positive 2/3. Don't forget the plus c. And again, if you want to leave it alone, that's perfectly fine. Just make sure that you type in your fractions properly on the sign, or you can change flip. Right? This flips upside down as 2/5. This flips upside down as 3 halves. Right, so it's 2/5 x to the 5 halves minus 39 over 10 x to the 2/3 plus a constant. Right. So notice, again, you just have to clean up your integral before you start doing anything. So it's a bunch of algebra at the beginning, and then you do a little bit of calculus. Right, so look at this last example. We've got the integral of 2x to the 4th minus 3x cubed plus 5 over 7x squared dx. Right, so just like earlier, there's no product rule, there's also no quotient rule. Right, so again, we're going to have to rewrite this and see if we can get it to something that we can do. So if I rewrote this as 3 division terms, right? The numerator divided by the denominator, right? And then I can split up the numerator into pieces. And so this is, if you look at just the coefficients, just like what I'm doing, I'm going to highlight the coefficients because I'm going to write that off to the side. Right, so 2 over 7 minus 3 over 7 plus 5 over 7. So right here, I have x to the 4th divided by x squared, you get x squared. X cubed divided by x squared will be x, and then this is x to the negative 2. All right. Now we're ready to do power rule. Right. Again, once we take integral, the antiderivative goes away, the dx also goes away. The dx tells us that you're using everything in the functions in terms of x, which is important to get to use substitution when we start introducing some variables. Right. Power rule, power by 1. Right. X to the first x squared over 2. And then again, be careful here. You are adding 1 to negative 2 plus 1 is negative 1. Right, if you want to clean this up, this is 2 over 21 x cubed minus 3 over 14 x squared minus 5 7 x plus a constant. So this is my antiderivative.